We begin Chapter 5, which is a study of integration or integrals. And integrals are this idea of kind of the reverse process of differentiating or taking the derivative. And it also includes the idea then of, if we think of it as the reverse in terms of maybe computation, we'll also be thinking of it in terms of like an application of adding things up. So it's a way to kind of add up really small pieces of things together. Let's first make more specifics about what I'm talking about. First of all, a definition. A function f, capital F, is the antiderivative or we'll use the word the integral of f of x if capital F prime, if when I take the derivative I get back to this little f of x. Okay, so here's an example. And the question says, is 1/3 x cubed, and maybe I'll write it like this, is capital F of x, which is equal to 1/3 x cubed, the antiderivative or integral of x squared? And let's call that little f of x, should we? Okay. And so the test of this is to find f prime, capital F prime, and see what it is. So let me do that. F of x is equal to 1/3 x cubed. I'm going to take the derivative. F prime of x is equal to 1/3. This 3 comes down, x, and then I get a squared there, right? And 1/3 times 3 is just 1. So that's x squared. And I know that my little f of x is also x squared. And since these are the same, then yes, f of x, capital F of x, is the antiderivative of little f of x. Okay. Now I have another question for us to think about. Is capital F of x, if I change it slightly, 1/3 x cubed plus 3, is that the antiderivative of f of x is equal to x squared? And if I take the derivative again of f prime of x, capital F prime of x, I again get x squared because the derivative of this 3 constant is 0. So the answer again is yes. Yes, this capital F of x, which is slightly different than my original one, is also the antiderivative of this little f of x. Okay, and it turns out that there are infinitely many antiderivatives for each function. And these all belong to some sort of family of functions. You see how these functions, my two functions, looked the same? So those two functions have this connection. They all differ by a constant. Okay? Okay, so, and you know, in mathematics, we don't like to go around writing this whole long thing. Capital F of x is the antiderivative of little f of x, or find the antiderivative. So we have this shorthand notation that we use when we want to do this process. That is, kind of go backwards from differentiation. And it's kind of this S-like shape called the integral of f of x, and we have this dx. This tells me which variable I'm talking about. And here's my antiderivative over here. And this is my constant that things can change by. Okay, so let's put some things in. This is definitely the indefinite integral, or just the integral of f of x, lowercase f of x. Let's see, this is called the constant of integration. And still here in this notation really is meant to mean capital F prime of x is still equal to this lower case f of x. Okay? But I say find the integral. This is, read out loud when I read it. It means find the integral of f of x, lowercase f of x. And so you don't really hear this term antiderivative all that often. You more often hear this term, the integral. Okay? Okay, so in the next video I want to talk about concrete ways to actually find these. So let me know if you have questions.